right, guys, we are going to talk a little bit more about how to date a fossil. So, how to give it an age, whether it's specific or relative. We're going to talk about how we can do that. All right. So, we've talked about the fossil record. We talked about how the oldest fossils are going to be down at the bottom because they've been sitting there the longest, and more of those sediments are going to pile on top of it. So, we've talked a little bit about how to figure out how old a fossil is and give it a little bit of an age. But we are going to dig in and do some more specific work with that today. So the first thing, we already talked about fossil records, and this is one of the most important things we need to remember. Um, we talk about a fossil record. It is a piece of paper that's giving us a guide. It gives us a table, an idea to follow along to see what fossils are roughly what age. So we're giving it a relative age. We're not giving it a specific age. We're giving it our best estimate. Okay. But the oldest layers are going to be at the bottom. Remember to think of it like a lasagna or a 7-layer dip. Those first layers are going to have been in the pan longer than everything else. Okay? So now, just to kind of give you a better image of this, we're going to talk about where those fossils lie. So this is a really flat option. There's not a whole lot going on. A whole lot hasn't changed over time here. So if you see flat layers like this in rocks, you know that this is the oldest layer. This is a little bit newer, and this is the newest layer. Okay, so you'll find the newest fossils at the top. These are a little bit older, and these are the oldest because they're down at the very, very bottom. Okay, now not all the layers on Earth will be flat like this, and we'll talk about what that looks like in just a second. But if we're trying to figure out a year or roughly a year for one of these ages, instead of just saying these are the newest and these are the oldest, we can use what we call index fossils. So in the fossil record, there are some creatures that only lived for a couple of years. All right. So if we say the most common one is a trilobite, okay? So if we say that we know trilobites only lived for, I don't know, 1,000 years, if we find a trilobite in this rock layer right here, we know that that rock layer has to be in that 1,000-year time frame. So if we know that trilobites only lived, I don't know, we'll say the 1800s. It's not the 1800s, it's much farther back in time, but I'm just giving you an example. If I know that the trilobites only lived in the 1800s and I find trilobites in this layer, I know that that layer is from the 1800s. Okay, so that's what I mean when I say an index fossil. All right, now when we talk about the way Earth's crust is shaped, we talked about the rock cycle, we talked about weathering and erosion, we talked about earthquakes and volcanoes and how things constantly change, and the fact that the layers in Earth's crust are not always going to be flat. Okay, so when we think about that, this is what it could look like. All right, so we lose some layers due to erosion, but we've still got these layers here. So these are going to be older layers. The orange and brown are going to be older layers, and this gray and dark brown up here, these are going to be newer layers. Okay, so these two, even though they're really close to each other, are going to be different ages. All right, because this was here, and then part of it got eroded away, and it was filled in with newer sediments. But these layers right here, the two orange pieces that are separated by that, they're still the same age, okay? We can talk about the same way when we talk about those index fossils. If we look at how things are shaped, if we look at where things are and how they match up, we can give an age to that rock layer. So we know that these two layers that I'm pointing at, those two layers are still going to be the same age. So if I find a trilobite here, and this is, I know the trilobites were only in the 1800s, this is going to be the same because they're the same type of soil. They've got the same color, and they probably have some of the same fossils there. So this would be the same age as this, okay? This is where we come in with the newer stuff and where things get kind of funny, all right? Now, when we talk about giving a more specific age or a more exact age for these fossils, we use what's called carbon dating. This can only be done in a lab setting. That means that when we look at these rock layers, we talk about relative age and we talk about the index fossils. That can be done in the field. That could be something, oh, there's a trilobite. I know this is from the 1800s. That's something you can quickly know. But if you want to have a more specific time range or a more specific age, you can use what's called carbon dating. And the reason carbon dating works is because carbon is present in all living things and it dissipates at the same rate from everything after it dies. Okay, so whether it be a tree or a dinosaur or a bird or whatever, carbon is going to decay at the same rate out of all these living beings. All right, that means that scientists can do a little bit of math and figure out a very close age for that fossil. But no, that doesn't tell us how old the creature was when it died necessarily. That's just telling us how long the creature has been dead. So we don't call it a fossil necessarily if the creature's still alive. But with that carbon dating, we can figure out how long that creature has been dead, how long it's been sitting in the ground like that. Okay? So we talk about the age of these fossils. That's what we're talking about. We're talking about how long the creature has been dead. All right? So keep that in mind. Now you'll have an opportunity to kind of practice with some of this information. So you'll have some questions pop up on your screen. So with each image up on your screen, you're going to be answering those questions. So this is the first picture. Then you've got the second picture. And you're going to answer the questions on your screen with this picture. And this is your third picture. You're going to answer the questions on your screen using this picture.